For the introduction, rail transport is a means of transferring of passengers and goods on wheel vehicles running on rails, also known as a track. Also commonly referred to as train transport. Rail vehicles are directionally guided by the tracks on which they run. Tracks usually consist of steel rails installed on ties and ballast on which the rolling stock, usually fit with metal wheels, move. Other variations such as slab track, where the rails are fastened to a concrete foundation resting on a prepared subsurface, is available. Rolling stock counters lower frictional resistance, so passenger and freight cars can be coupled. Power is provided by locomotives which either draw electric power from a railway electrification system or produce their own power by diesel engines. Most tracks are accompanied by a signaling system, safe and capable of high levels of passengers and cargo utilization and energy efficiency, less flexible and more capital intensive than road transport when lower traffic levels are considered. Innovation of lightweight structural component is carried out for better performance. Combination with carbon fiber reinforced composite allows to improve fabrication process, weight saving, space saving, fire resistant, reduce noise, and improve heating and cooling performance. To assess the shear and the composite strength of the proposed solution, both 3-point bending and compression tests were carried out. This geometry is widely used since offers a high stiffness of strength-weight ratio. Styling flexibility, reduce vibration and harshness, enhance corrosion resistance.
For fundamental base and principles of the composites material used in rail and train, for fiber reinforced plastics (FRP), which modular toilet for coaches, mold the inner frame of the rail and make the main door for non-AC coaches of railways, are made of a polymer matrix reinforced with fibers such as glass, carbon, or aramid. Other fibers such as paper, wood, or asbestos have been used. The strength and elasticity of FRPs are mechanically enhanced by stronger, stiffer reinforcing filaments or fiber materials. Two-dimensional and three-dimensional orientations of reinforcing fiber is included in fiber reinforced plastic. The four major ways to carry out fiber perform is through the textile processing techniques of weaving, which is most commonly used, knitting, braiding, and stitching. Molding processes such as bladder molding, compression molding, mold by using autoclave and vacuum bag, mandrel warping, wet layup, molding using chopper gun, filament winding, pultrusion, and resin transfer molding is conducted depends on the input and output. For carbon fiber reinforced polymer (CFRP), which is used as outside and inside cover panels for roofs and train bodies, in constructing floor body frames, and as insulated roofs for electrical application, is an extremely strong and light fiber reinforced plastic which contains carbon fibers. It often binds with thermoset resin such as epoxy or thermoplastic polymers such as polyester, vinyl ester, or nylon. It usually uses polymer resin such as epoxy to bind the reinforcement together. Reinforcement by carbon fiber provided the strength for the structure and enhanced the strength and rigidity that measured by stress and elastic modulus of CFRP. The arrangement and proportion of carbon fibers affect the properties of CFRPs. It is affected by the environmental effects such as temperature and humidity, but it has excellent corrosion resistance too. Primary element of CFRP is carbon filament produced from a precursor polymer such as polyacrylonitrile, rayon, or petroleum pitch. Many CFRP parts are created with a single layer of carbon fabric that is packed with fiberglass. Ways to manufacture CFRP involving molding, vacuum bagging, and compression molding.
I'm going to present about the advantages of the composite material used in rail and train. It is carbon fiber reinforced polymer. First, it has low weight but great mechanical properties. This also can reduce vibration, make less noise, and increase passenger comfort. Secondly is resist to corrosion. It also has low maintenance costs. Third, low thermal conductivity that enables the air-conditioned coaches have low energy consumption. Secondly is fiber reinforced plastic (FRP). First, it allows the alignment of the fibers of thermoplastics to suit specific design programs. Second, resist to corrosion, no need frequent maintenance and service life improved. Third, contains lightweight due to its low weight to strength ratio. It also needs less energy to keep functioning. Fourth, has high versatility since FRP can mold almost any configuration with minimum tooling costs.
My name is Muhammad Fakul Fidaus bin Rosdin. Will explain about the comparison of materials used in a rail and train. Now and previous. In the previous material or train, humans fit plates of cast iron to the upper surface of the wooden rail to allow a variation of gauge to be used. At first, only balloon loops could be used for turning, but later, movable points were taken into use that allow for switching. Then a system was introduced in which unflagged wheels ran on L-shaped metal plates, and this became known as plate wheels. French rail is invented in 1787. Then here comes the plate rail. After this, double track plateway is invented. Meanwhile, an all-iron edge rail and French wheels has successfully invented in 1789. Then in 1796, edge rail is manufactured. Nowadays, trains is made of aluminium foam which is stronger, lighter, battering a crash than fiberglass or regular old metal. The aluminium foam is built like a sandwich between two pieces of aluminium. That is 2 to 25 mm thick layer of the foam, which actually is a low density. No glue is used since the layers are held together by metallic bonding. The electrostatic attraction of negatively charged electrons and positively charged ions. So the trains are 20% lighter than traditional fiberglass. The outer shell is so stiff and there are no ribs inside. Field test of aluminium foam in which force is applied to pull apart the layers of the material to destroy the foam interior instead of breaking the bonds between the layers, demonstrating the strength of the bonding. Aluminium foam has a very high and comfortable impact resistance, especially for small impacts like stones, bottles or just birds.
There are 7 processing methods used in rail and trains. First and foremost is design, which include bidding process, sign contract, meeting and discussion, tasting, and lastly prepare document. Second step is manufacture the part separately before we combine it. Then we combine the part that we manufactured such as body shell, sole bars, runners, bolsters, transom and chamber. After that is fitting by inspection, straightening jig, printing, wiring, piping, installation and accessories. When the welding is finished on traditional made body shell, the complete shell is moved to an inspection and straightening jig. Straightening may involve using a large hammer with a blow touch to hit the skin, or it may employ a more sophisticated method such as attaching a magnetic panel to the outside of the skin and a thick panel to the inside. This thick panel will have a series of equally spaced holes through which heat is applied using a multi-nozzle blow touch. The heat applied has the effect of stretching the skin of the body due to the spot heating, causing the panels to strengthen. Vacuum clamping is also sometimes used. Painting for trains has become the norm again, and some interesting color schemes have resulted. A car builder will need to have a fully equipped paint shop and drying facility, together with all the necessary fume extraction and fire protection equipment. Then the important step is testing. We do final check and integration check before we deliver it. Vehicles being shipped by road or sea need to pack properly. It is usual to ship bodies and bogies separately. If the shipping involves a sea passage, careful protection is required for the body and parts vulnerable to manage by seawater or just the salty atmosphere. Bogies are packed so that the vibration of the suspension does not create wear. The shipping process invariably involves crane edge, and it is essential to ensure the docks know how to handle railway vehicles, which are very difficult to load on and off ships without damage. The delivery route must be surveyed to ensure that there are no obstructions.